So in the last video, we talked about, we were given a table of values and can we decide if this is linear or not? The answer is yes. We got to find the rate of change or the slope. So now what the question is going to be is if we can find that slope and we can know it's linear, can we write the rule, the function, the equation? And the answer is yes to that too, using things we already have done in the past and hopefully know how to do. So it says a function assigns the inputs shown, the corresponding outputs given in the table below. So when we talk about this language, again, the language is changing, but the work we're doing is not. Remember, this is our x values and this is our y values. And we input the x and we get out the y value. That's why we have like y equals, right? Y is called dependent. It's dependent on our x values. So it says, do you suspect the function is linear? Compute the rate of change, the slope of this data for at least 3 pairs of inputs and outputs. Kind of sounds like a question on your homework, hint, hint. All right, so we're going to use our slope formula. Difference in the y's, y sub 2 over minus y sub 1 over the difference in the x's, x sub 2 minus x sub 1. All right, and then keep in mind with these points, these are ordered pairs. So I'm going to do, I have to do at least 3. So I'm going to do those 2. I'm going to go the point 1, 2 and the point 2, negative 1. All right, should look really familiar because we just been doing this a lot. X sub 1 and y sub 1, x sub 2, y sub 2. Okay, putting it in this formula. Difference in my y's. So you notice here I'm going, okay, negative 1 minus 2. Why am I doing that? Right here. Negative 1 minus 2. Over x is here. Notice I'm starting at x2, x sub 2, 2 minus 1. All right, and that is going to give me, change, negative 1 plus a negative 2 is negative 3 over 2 minus 1 is 1. We get negative 3. Okay, so the first one's negative 3. Let's do the next 2 points here. Let's do the point 4, nope, sorry. Started here. 2, negative 1, and 4, negative 7. X sub 1, y sub 1, x sub 2, y sub 2. Okay, throw it into this formula. Negative 7 minus negative 1 over x sub 2 minus x sub 1, 4 minus 2. Keep, change. Subtracting is the same thing as adding the opposite. Negative 7 plus 1 is negative 6. 4 minus 2 is 2. Negative 6 divided by 2 is negative 3. Looking good. It said try at least 3, so let's do these 3. Okay, because again, you could jump around and you could try it between these points and these points, but if it's between all those, between each one of them, it's going to be between all of them. All right, so now I'm going to do 4, negative 7, and 6, negative 13. X sub 1, y sub 1, x sub 2, y sub 2. All right, difference in my y's. Negative 13 minus a negative 7 and 6 minus 4. Keep, change. Negative 13 plus 7 is going to be a negative 6 over 6 minus 4, which is 2. Negative 6 divided by 2 is negative 3. Yay! Okay, they all work out the same, so we're going to say that this function is linear. They all have the same rate of change, the same slope. So that's what we said in the last video, that if they're all the same, we know they're linear. Excuse me. Sorry to sneeze in that video there. But now it says, what equation seems to describe the function? So we're taking it to the next step. Remember, I said at the beginning we want a deeper understanding of these functions. We want to write the equation, write the rule, write the function, whatever it seems to say here, okay? So I think we've done this before when we were trying to put things in slope-intercept form. So what equation? Remember, we know we have that. We know we have y equals mx plus b. All right? We have our m. M is negative 3. It's our slope. We don't have our y-intercept. So what we've done in the past, remember, is you pick a point. Doesn't matter which point because these all lie in a line. They have the same slope. And plug it into the equation. So maybe I will definitely use m as -3, but I could use 1 and 2 here as my ordered pair. Or I could use 2 and -1, or any of them. That's my x value, that's my y value. So now remember what we're going to do is plug this stuff in. So instead of saying y equals, I'm going to say what y is. 2. 2 equals my m, -3, times my x, 1, plus b. I don't know what b is yet. So I simplify and solve. -3 times 1 is -3. And then I add 3 to both sides. 2 plus 3 is 5. That cancels, and I bring down my b. So b equals 5. So I know my m, and I know my b. Now you can write in slope-intercept form. Y equals -3 times x plus 5. Okay, so now we have written the rule, the function, the equation that represents this table of values. Okay, so the next one wants us to check it. It says, as if you do not verify the rate of change is constant along all inputs and output pairs, because we didn't kind of jump around there, check that the equation you found in part A does indeed produce the correct output for the 4 inputs. I'm not going to do all 4, I'll do a couple of them. Okay, so let's say we're going to start with x equals 1. All right, so here's my equation right here. I want to plug 1 in for x. Input it in for x and see what you get for y. So y equals -3 times 1 plus 5. Y equals -3 times 1, which is -3 plus 5. Well, -3 plus 5, I keep feeling I'm saying it over and over, is 2. So let's look. X is 1, y is 2. Let's go up to our table here. If we input a 1, what do we get out? A 2. So it works. All right, and I want to just try, let's do 4, okay? Nah, you trust me, I'm sure. You guys will trust me that they work for all of them. All right, so again, let's plug 4 in now. Let's input 4 in for x. See what we get for an output. Y equals -3 times 4 plus 5. So y equals -3 times 4, which is -12 plus 5. And if we add -12 and 5 together, we get a -7. So if we input a 4, we get out -7. If we input a 4, guess what? We get out -7. Okay, so we're just verifying that it works. That's what we did here. We knew our knowledge of slope and rate of change to find that, and then our knowledge of writing an equation in slope-intercept form to write a rule for that table of values. The last question here says, what will the graph look like? Well, what type of equation function is it? It's linear, right? So if it's a linear function, what will the graph of a linear function look like? I know you're all thinking this. The graph will be a straight line represented. So now this again, over our understanding, we're going to up our understanding here. So we're going to take it a little farther. What is it represented by? Well, it's represented by the equation we wrote. Y equals -3x plus 5. And then let's just add one more thing. Going through, I don't care too much about this point, but again, we're expanding our knowledge. Going through these points, 1, 2, 2, -1. Where are these points coming from? Right here. 1, 2, 2, -1, 4, -7. And 6, -3. Okay, so again, no surprises in this lesson. We're deepening our understanding of linear functions. We're pulling in the fact that we've worked with constants, with slopes, and now we can use that information to determine if the relationship between some points is linear, and if it is, we can write an equation.